So, kia ora, I am Elizabeth Pretty, and on behalf of the New Zealand Association of Resource Management, thank you for registering for the webinar on mapping acid sulfate risk occurrence in the Waikato region. For those of you who are not familiar, NZARM is an association for professionals involved in natural resource management, particularly the land and water space. NZARM webinars are produced out of the NZARM Capability Building Project, a 3-year program where NZARM has partnered with the Ministry for the Environment and regional councils to support the upskilling of individuals across the sector. We are lucky enough today to have Jonathan Caldwell, a senior scientist from Waikato Regional Council, to chat with us today. Prior to joining WRC, he has worked as a research assistant at the Wool Research Organisation of New Zealand. Now, before I hand over, if you have any questions throughout the webinar, could you please use the Q&A function and we will answer these towards the end. Thanks again, and I will now hand over to you.
Kia ora. Thank you for inviting me to present today on a recent project we've been doing on acid sulfate soil mapping in our region. So I'll just share my presentation, and hopefully that's all visible to you now. Okay, so I thought I'd just start really by explaining what acid sulfate soils are. They are naturally occurring soils, sediments and peats containing iron sulfides, typically found in low-lying areas and formed during historic sea level rise and inundation of land close to coastal areas. But it's important to note that they can be found well inland. And the source of that sulfate is from the marine environment. The seawater comes incorporated into the sediments, and under reducing conditions and bacterial or microbial activity is reduced to hydrogen sulfides, which can then react with any sort of metals such as iron to form those iron sulfides. So what is actually the issue with these acid sulfate soils? They're typically fine when in a waterlogged state, but it's when those soils are drained or excavated or the groundwater table drops during sort of extended drought periods that they can become exposed to the air and oxidized. And it's when they generate sulfuric acid and produce acidic conditions in the environment. So that acidity can immobilize naturally occurring metals and nutrients in the soil profile, which can then be transported through to groundwater and waterways. And it's the soil, acid sulfate soils are sort of classed into two types depending on whether they've undergone oxidation or not. So the actual acid sulfate soils are the ones that have already been exposed to oxygen and are highly acidic. Then you have the potential acid sulfate soils that have not yet been exposed and have not produced acidity, but have the potential to do so on exposure to oxygen. And typically what is found is that the actual acid sulfate soils will be found higher in the soil profile, with the potential acid sulfate soils below them. So there are a number of issues and concerns around acid sulfate soils. They can have a lot of effects on both infrastructure and the environment, including aquatic and terrestrial environments. They release a lot of these metals such as aluminium, iron, copper, zinc, etc. A lot of the nutrients such as phosphates, nitrates can be released into waterways and result in toxic algal blooms, also resulting in deoxygenation of the water bodies. If groundwater is being used for potable sources, that can have an effect or pose a risk for drinking water contamination. They have been known to release noxious gases such as hydrogen sulfide when disturbed. You can have emission of greenhouse gases. So there's a range of issues of concern when we're looking at acid sulfate soils. Some of the things to look for in waterways and concrete infrastructure that are impacted by acid sulfate soils, they can have an orange-coloured staining as a result of those iron oxides leaching out. Naturally occurring aluminium can be released in large amounts into waterways. which can result in usually quite turbid waterways suddenly turning very clear or milky blue-green during over quite a short period of time, sometimes overnight, due to the natural flocculating properties of some of these compounds. Orange scums associated with iron oxide precipitate can also form on waterways. And signs of poor vegetation growth can also be an indicator that acid sulfate soils are present. And release of sulfurous odours associated with hydrogen sulfides can also indicate the presence of acid sulfates. In the field, there can be some field testing that you can undertake to identify potential presence of those soils. A pH test of soils identifying pHs of less than or equal to 5 can indicate highly acidic soils. Below 4, it's an indicator that you may have actual acid sulfate soils. And if you treat those soils with a 30% hydrogen peroxide solution and retest the pH, and if the pH drops below 3, this is an indicator you may have potential acid sulfate soils. Or if the pH of the soil before and after oxidation is a more than a 2 pH unit shift downwards, this is also an indicator that you've got potential acid sulfate soils. But you will need to follow up that confirmation using lab-based analyses such as the chromium reducible sulfur analysis. So where are they? They are well recognised as a problem around the world, including Australia and the UK, where they have well-established policy and regulation for managing and controlling the effects and protecting infrastructure. Likewise, Sweden, Finland, low-lying areas like the Netherlands have also looked at, investigated and established policy and regulation around acid sulfate soils and have mapped them. The presence of acid sulfate soils in the northern parts of New Zealand has been known about since the 1970s, but it's only more recently that they've been investigated, typically in association with quite large infrastructure projects. More notably, as many of you may well be aware of the Northland Ruakaka development, failed development, the Marsden City development, where the stormwater infrastructure failed very early on in the subdivision development due to exposure to acid sulfate soils. In the Auckland region, there was the Puhoi to Warkworth motorway, which included some significant investigations of acid sulfate soils along that route. And there's been ongoing development at Auckland Airport, which has identified acid sulfate soils around that area. As well as more recently, there are some upgrades to the Wellsford wastewater treatment plant upgrade, which has identified the presence of acid sulfate soils. In Waikato, we have had some recent upgrades to some of our pump stations that have involved acid sulfate soil investigations. There is also a proposed solar farm project in Whitianga, which has identified the presence of acid sulfate soils. Whanganui, there was a proposed three-water stormwater project that involved investigation of acid sulfate soils, and even as far south as Dunedin, where some pipeline upgrades resulted in the requirement for acid sulfate investigations. In Auckland in 2016, the Auckland Council had an acid sulfate soil map developed for them by GHD. The map here shows areas of high, medium, low and negligible probability of occurrence. And this is really probably the first example of a region-wide acid sulfate soil mapping exercise in New Zealand. In the Waikato, we've had some awareness of issues for about 15 years where we've identified regular fish kill events in the Aka Aota'a drainage area, which is to the northern end of our region since 2007. So the Aka drainage area is on the northern banks of the Waikato River, just before it discharges to the sea, just close to the border with Auckland. And a series of events were have triggered an investigation in 2020 to try and establish really what was happening here. We found that these fish kill events were typically coinciding with observations of high clarity in what is usually quite turbid drains or streams, and we had a really useful landowner farmer who was very observant and would often take photos for us, and remarked that the river or stream adjacent to his land had gone clear overnight. Sometimes iron flock were also observed. And a intensive pH acidity monitoring or pH monitoring exercise was undertaken in a number of drains, about 6 or 7 drains around this drainage area between 2014 to 2016, and it was found that over winter time the pH often dropped below 6 pH units, certainly well below the ANZ guideline protective range. Also associated with changes in water clarity, sulfate to chloride ratios increasing above 0.5 during winter, which is also an indicator of the presence of acid sulfate soils. And there were some significant increases in dissolved metal concentrations, namely aluminium, zinc, copper, etc., which were well above 95% and in some cases well above 80% protection values. So adverse conditions were found to be occurring for up to at least 3 months per year over that wintertime period. And these conditions were generally aligned with years where we had very low rainfall, so drought conditions typically over the summer period, followed by quite high rainfall events in the autumn and winter, which were likely flushing through the acidity that had formed over those drought conditions. Also, our catchment management service staff had been identifying some unexplained accelerated deterioration of infrastructure for some of our pump station and floodgate assets. And so all of this coupled together provided some strong indicators that water quality was being impacted seasonally by the presence of acid sulfate soils due to those fluctuating groundwater levels. So following this, we had some pump station upgrades, namely the Mangawhero pump station in the Aka area to the far north of our region, and the Churchill pump station in Rangariri. And both of these upgrades involved geotech testing, which had some acid sulfate soil investigations undertaken at the same time, which identified their presence. Some further evidence has been obtained from a more wider investigation of soils across the Aka area and in Hauraki around some of the pump stations. And there was also knowledge of a acid sulfate soil investigation undertaken in 2007 as part of the Hampton Downs landfill development. And more recently, there is the solar farm proposal for Whitianga, where acid sulfate soils have also been identified in the location where excavations will occur. So over the last year, we've engaged a GHD to develop an acid sulfate soil probability of occurrence map for the region. It's based on several inputs, including GNS's geological database, soil types, soil classifications, texture and order, and elevation, wetland layers, and land cover databases. All of that data used to inform acid sulfate soil probability of occurrence. So the intersection of the worst risk factors for acid sulfate soils produces outputs that are weighted to provide negligible, low, moderate, and high probability of occurrence. The map was then refined based on soil sampling at 100 locations across the region to a depth of 2 metres. So this ground truthing provided more accurate predictions and refinement of that map. The map and methodology was reviewed by Manaki Whenua Land Care Research. There has been some recommendations around further refinements that can be done to improve the accuracy of the mapping. One of these is looking at more accurate elevation data, which we can now obtain from a regional LiDAR data set, which has now become available, which wasn't available at the time. So here we have the map indicating high, moderate, low and negligible probability. So the high probability areas are mainly in the Waikato and Hauraki basins. There is also a report produced by GHD which discusses the methodology, the results of the mapping outcomes and the results of the soil sampling, ground truthing. So our intention is to make the map publicly available along with the technical report, which is just going through our publication process at this stage. We will be obviously making the geospatial mapping layer available at that time. So probably in the next few weeks, we're looking at that becoming available. We will intend to use the mapping to inform Regional Council guidance for development and infrastructure projects, to support maintenance work on controlled assets such as our pump station, floodgate and drainage management. And we'll also look at informing it to help inform develop policy and regulation for minimising environmental impacts during earthwork projects, and also for protecting harm to infrastructure. We will look at some further refinement of the mapping though before we develop policy and regulation. So looking at what existing regulation and guidance is out there in New Zealand, we obviously have Regional Council's RMA functions under Section 30 along with enforcement roles under Section 15 that are relevant to managing and controlling the effects of acid sulfate soils. Territorial authorities have their RMA functions around land use, natural hazards and subdivision under Section 31, Section 106 and Section 244C, and also the Building Act, which relate more to infrastructure. But we are currently lacking specific national, regional or district policy regulation and guidance. Apart from a few examples, we have obviously resulting from the failed Marsden City development, Opus, who worked in with Whangarei District Council to do some mapping and produce some guidance or a policy guide around protecting infrastructure during new building developments in those higher risk areas. I gather that they have been looking at some more this in more detail recently with their Plan Change 1 review, which may be looking at introducing some rules under their natural hazards chapter. And likewise, Northland Regional Council went through a plan review a few years ago, and there were some submissions seeking a decision to introduce some rules into the regional plan as well, although that never eventuated. And PDP has produced an acid sulfate soil management plan for excavations and works around the Auckland International Airport site. With regards to the Waikato Regional Plan, we don't have any specific plan rules or policy specifically identifying acid sulfate soils as an issue for control and management, but the following is potentially relevant under Chapter 3, our water module. We have rules around discharging of water pumped from drainage and flood control schemes. So we need to manage and control the effects of that drainage water on receiving waters when it's flushed out and released. We also have a general rule for a discharge of a contaminant directly or indirectly into water, which could equally be applicable to acid sulfate soil discharges. We have our groundwater rules under this water module as well, which is relevant to any activities that will take groundwater or dewatering projects where groundwater depth is going to be impacted. Chapter 5, we have our land and soil module, which acknowledges that environmental processes such as surface runoff, acid drainage and leaching pose a hazard to the environment. Therefore, discharges must be undertaken in a manner that do not have adverse effects on aquatic habitats, surface water quality or groundwater quality. So this chapter has some clear indicators that we need to be managing acid sulfate soils, the effects of acid sulfate soils during earthworks projects. So just moving on to some of the activities that pose the greatest risk when we're looking at managing acid sulfate soil disturbance. Obviously, direct disturbance through excavation poses the greatest risk, especially when you're excavating greater than 0.5 metre depth. You're excavating large volumes and you're excavating close to waterways. There's also the indirect disturbance through interception of groundwater or dewatering, where you are changing the water table elevation, and this can increase that potential risk for oxidation of acid sulfate soils. Likewise, maintenance of drainage channels can disturb sediments where you have sulfides present, and this can result in oxidation of those sulfides and lead to acid release. Floodgate pump station operation can also exacerbate acidic and elevated contaminant effects within drains if not released and flushed. And that's really one of the reasons why we think we've seen some of those fish kill events where some of the drainage channels haven't been flushed out and there's been an accumulation of acidity and heavy metals in those waterways and drains. So we're looking at developing preliminary guidance. Really what we're looking at is if geotechnical or other soil investigations are required and there is a suspicion that acid sulfate soils may be present, then you should consider some concurrent investigation for acid sulfate soils. If the presence is confirmed, then you should develop an acid sulfate soil management plan and implement it in consultation with the Regional Council to effectively anticipate and manage the potential impacts of those activities. And there are a number of guidelines available already through Australia with regards the Queensland guidelines, the Western Australia guidelines and the national guidelines. So the Queensland guideline provides some specific action criteria for managing the disturbance of acid sulfate soils, and these are based on a calculation of the net acidity. So the net acidity is the sum of potential sulfidic acidity plus actual acidity and retained acidity minus the acid neutralizing capacity. So you need to take into account all of these factors when calculating net acidity. As taken into account, the neutralizing capacity is important because there may be some buffering capacity from naturally occurring carbonates in the soils, which can reduce that overall net acidity. And the recommended lab analysis for this is the chromium reducible sulfur suite, which is currently only provided by Australian labs. And the Queensland guidance provides these net acidity criteria in a table form here where we are classifying that net acidity trigger limit whether depending on whether you're disturbing over 1,000 tonnes of material or less than 1,000 tonnes of material. So the trigger limit is 18 if you're disturbing over 1,000 tonnes, and if you're disturbing less than 1,000 tonnes, you can look at having a higher acidity net acidity based on justification or evidence that you have got low permeability soils such as heavy clays or silty clays. Therefore, you may be able to allow a higher action criteria before you would be required to start looking at developing an acid sulfate soil management plan. So based on exceedances of those criteria, you would want to develop an acid sulfate soil management plan for handling the treatment and disposal of those soils if disturbance is avoidable. However, the following hierarchy of options should always be considered. Can you avoid disturbing those acid sulfate soils in the first place? If you do need to disturb them, can you minimise that disturbance? There are a lot of construction techniques that could be employed to reduce the amount of soil you actually have to excavate and bring to the surface. Can you reduce the amount of oxidation by when you bring those soils to the surface? Can you cover them, seal them up, prevent them from drying out and reducing their contact with air? Or can you maintain groundwater levels while you are undertaking those excavations? You may need to neutralise those soils by mixing them with alkaline agents such as agricultural lime, or you may need to rebury those soils at a depth below groundwater table or dispose of them to landfill. So the following controls and procedures are commonly used. You have containment of excavated soil for testing and treatment, and this is usually where you design a low permeability pad, possibly on clay, and you can then mix your soils to neutralize them with calcium carbonate, and typically you're required to increase, based on the net acidity, multiply that by 1.5 times to ensure that all soils are neutralized. And here we've got a diagram of a typical treatment pad where you have leachate collection drains either side and bunds to the sides of those to prevent any overflow. And you can then collect that leachate and treat it typically with lime prior to release. And then you have the option of handling and disposing via reburial or off-site disposal. You may need to treat that soil before reburying it below the groundwater table. You may also need to treat that soil with lime before disposing it off-site. Some sites may require that. There is a managed fill site that's recently been authorised in the Waikato region, operated by Gleason's near Huntly, and they will be able to take untreated acid sulfate soils because they are developing an acid sulfate soil treatment facility at that location. Now, when considering catchment management options, which are all really more going to be applicable to regional councils, there are some options that have been trialled in Australia, development of aerobic wetlands, which can filter out the acidic drainage water from those problem areas, but they do come at quite a high maintenance cost, and it does require some large areas of land, productive land, to be retired, which can be controversial. Permeable reactive barriers along waterways can also be implemented to treat the acidic groundwater and neutralise it before it gets to the streams and drains, and this can involve lining the base of drains with limestone or limestone barriers beside the drains, but they can be prohibitively expensive, especially when you're looking at a large catchment. And there is also wet acid containment, where you can reduce the rate of discharge from groundwater to the drains by raising the levels in drains using sills, drop boards, weirs, penstocks, or completely filling the drains and reinstating natural drainage lines. Lastly, you can also look at reducing the overall number and depth of drains, and wherever possible reconfiguring them. So rather than having really deeply incised drains, you can make them wider and shallower. And you can also revert the land to wet pasture grazing, which is an option that has been looked at in Australia, but has met some resistance by farmers just due to the unknown production and quality from using those native wet lands. So lastly, I just wanted to talk about a recent implementation of that acid sulfate soil map that we've had developed. Our water quality scientist, Dean, has been looking at overlaying the regional state of environment water quality monitoring sites over our high-risk areas, which are identified in orange here. And so the first water quality site he's looked at is the one identified by that red circle there. This is right in the middle of our Aka Ota drainage area where we've had these fish kill events in the past. Currently, that site has had monthly grab samples for turbidity, pH, electrical conductivity, the normal suite of nutrients, and chlorophyll A, as well as E. coli, along with dissolved oxygen and clarity. So this site is then going to be complemented with an extended suite which will include alkalinity, chloride, sulfate, and dissolved metals, along with continuous monitoring of turbidity, pH, electrical conductivity, and depth sensors, which can be telemetred back to an online dashboard, which will display some real-time data and give us alerts when things are turning pear-shaped. So it will inform our understanding of what's actually happening, what the impacts of acid sulfate soils are having on these waterways in this area, especially when we've had some drastic changes in the groundwater table. So it will provide a proof of concept for expanding that dashboard and monitoring network for other high-risk acid sulfate soil sites around our region. Additionally, we're already looking at adding a suite of acid sulfate soil contaminant indicators to the monthly grab samples for other high-risk sites. So in summary, we've identified over the last 15 years a series of fish kill events that triggered our investigation and identification that acid sulfate soils were having some quite significant environmental effects in the lower Waikato and Hauraki catchments. And this really led us to develop a probability of occurrence map, or at least engage GHD to do that for us, which predicts high probability of occurrence mainly in the Waikato and Hauraki basins. We do note that we will need to look at some further refinement to really provide some more robustness to developing and informing policy plans and rules around this. But we are going to make the map available along with the report within probably the next few weeks. And as I said, this map will help inform future proactive policy and plan rules and guidance for avoiding or minimising harm to the environment and infrastructure due to the presence and disturbance of acid sulfate soils. So yeah, thank you. Happy to take questions.
Awesome, thanks, Jonathan. We do have a few questions here. So the first one we've got is, what criteria were used to classify the areas into high, medium, and low, and how was this weighted?
Okay, so we've got a number of criteria. So obviously, soil type, geology, elevation, soil classification. There is a number of these criteria that were used to classify areas, and they were given a weighting depending on their intersection of how many of those factors intersected. I can certainly provide Well, the report that's currently going through our publication process will be available very shortly. So it details in quite a lot of detail how that was weighted.
Cool. So when that report's out, hopefully we'll be able to share that around and answer those questions in more detail. Cool. We've got another one here. Does or will the council offer any incentives or funding to support stakeholders or farmers in managing their sulfate soils?
Yeah, it's a good question. I don't have an answer for that yet. I know it's always good to be able to encourage good practices, so we do have offered funding for various things to landowners in the past for various projects to improve their impacts on the environment. So I wouldn't rule it out, but it's something that would still have to go through quite a lot of decision making, before we arrived at anything around that.
Cool. I've just got one last one here. You've mentioned that LiDAR wasn't available when the map was being created, but are there any other existing limitations right now with the mapping?
Yes, there are some other limitations. One of them is really around ground truthing. Obviously, 100 locations across the region is not actually huge when you're looking at the region. There were some difficulties in landowner permissions to get onto some of those sites, so we didn't always get the locations where we exactly wanted. There's some additional SMAP data that wasn't utilised at the time that could be used to help improve and refine the map risk outcomes. Lauren, I see you're on there, and you did a great peer review for us, so you've got some great recommendations which we've taken on board and we'll hopefully take on board with further refinement.
Awesome. Thank you. I think that's all the questions there, so we'll wrap it up. But thanks, Jonathan, for presenting today and everyone who has registered and attended. This webinar has been recorded and will be made available shortly after this ends, as well as on the NZARM website. Thank you.
Thank you.